This paper presents PM4Animal, a scriptable parametric modeling interface designed for conceptual animal sculpture design. This figure illustrates the overview of PM4Animal's framework. PM4Animal's pipeline begins with Blender's basic quadruped skeleton. Then, PM4Animal's skeleton editor loads this skeleton into the Unity editor by extending it with hierarchy settings and NURBS control points. Then this quadruped prototype is manually modified in Unity editor for modeling a rhinoceros. After that, the NURBS surfaces of the modified quadruped prototype are generated with PM4Animal's NURBS editor and then exported as NURBS files. This is a Java flat script that automatically loads the NURBS surface symmetries, deforms them with parametric functions, and saves them into an object file. PM4Animal is based on the PM4VR's framework, which includes a compiler architecture that interprets this Java flat script input and communicates with the Unity editor's SteamVR plugin for immersive parameter tuning in VR. As the last step, the parametric design output of the object file and its skeleton are imported into Blender for pose editing, where the surface heat diffuse skinning technique calculates the skinning weights. This way, the parametric animal sculpture's pose can be edited in Blender. Finally, the parametric animal sculpture design process is completed. The prototype modification process is an important step in generalizing the default quadruped skeleton to match other types of quadruped animals. PM4Animal's skeleton editor provides several key features to facilitate the prototype modification process, including load sketch, update bone, update selection, export skeleton. Load skeleton operation can automatically load skeleton and control points data from the PM4Animal.bones and PM4Animal.control.points files. While modifying the positions of a bone's head or tail, the update bone operation can automatically update the bone's positions so as to match its head and tail. The update selection operation occurs when the selection of a bone's head or tail is not the parent of the rest part of the skeleton. This case will result in the fact that the transformation on the current game object will not be applied to the children. Therefore, the update selection operation will automatically switch the selection to its grandparent to avoid this happening again. This example showcases the manually modified quadruped prototype for modeling a real-world animal, in this case, a rhinoceros. This modified prototype skeleton and NURBS control points are exported into the PM4Animal.bones and PM4Animal.control.points files by pressing Ctrl+E, which triggers the export skeleton operation. These are the NURBS surfaces of 7 animals designed from quadruped prototypes modified by PM4Animal's skeleton editor. These are parts of Java flat scripts that define these 7 animal sculpture designs' parametric functions, whose corresponding NURBS surfaces are shown in the previous figure. These are parametric animal sculptures designed with PM4Animal before pose editing using the parametric functions shown in this figure. These are parametric animal sculptures designed with PM4Animal after pose editing using the parametric functions shown in the previous figure. For testing the PM4Animal interface, this video records a preliminary user study conducted in a virtual gallery setting, where participants were tasked with interactively adjusting design parameters to create conceptual animal sculptures using the PM4Animal. During the study, the participants were introduced to the interface through a brief explanation of the parameter panel, after which they used a VR controller to iteratively refine the virtual animal sculptures in real time by manipulating parameters displayed on the sliding bars. Following their interactions, participants exported the designs into Blender to pose and perform edits, allowing the study to capture insights on how the tool integrates with traditional workflows. Key findings revealed that novice users appreciated the system's intuitive interface and the ability to experiment with design parameters without prior scripting knowledge, while valuing the scriptable functionality for creating complex, customizable designs. Meanwhile, Users find a low learning curve when understanding the relationship between parameters and their visual impact. Overall, the study demonstrated the effectiveness of PM4Animal in enabling both creativity and precision within an immersive environment, validating its potential as an XR prototyping tool for advanced parametric design in the XR context. This is the end of the video. Thanks for watching.